Hello everyone, today we are going to see about Python operators. Python operators. So there are many types of operators in Python. So we see one by one now. Let me change the name. So Python has totally 7 main types. The first one is arithmetic operators. The second one is assignment operators. Third one, comparison operators. Fourth one, logical operators. Fifth one, identity operators. Sixth one is membership operators, and seventh one is bitwise operator. So each operator have their own distinction and own way of calculating, and they have their own usefulness in Python. So we will see first arithmetic operator, arithmetic operators, addition, subtraction, multiplication, division, floor division, modulus, exponentiation or power. Arithmetic operators are used for mathematical calculations. So there are totally 7 arithmetic operators present in Python. Those are addition, plus, subtraction, minus, multiplication, asterisk, and division, and floor division, modulus, and exponentiation, double star. Okay, remember addition is plus the mathematical notation, subtraction mathematical notation minus, multiplication asterisk, division single slash, floor division double slash, modulus percentage simple, exponentiation or power double asterisk. And what is the difference between division and floor division? So division will give results in decimal point. Floor division will give results in integer. Okay, so that is the basic difference between division and floor division. And what is modulus? Modulus is nothing but remainder. It will give remainder unless the result of the division and floor division. Division and floor division will give quotient in decimal point and non-decimal point. Exponentiation is power, and addition will give sum, and minus will give difference. Finally, the multiplication will give product of 2 or more numbers. Let's quickly see the codes of the arithmetic operators. Let's say the variable is 10 for A and B for 3. First we go addition A plus B, and subtraction A minus B, A difference B, and multiplication A product B, division A slash B, and floor division A slash B, and for remainder A percentage B, and for exponentiation A power B. Let me type here integer. Okay, no, addition, subtraction, multiplication, division, floor division, and remainder or modulus, power. Let's wait for the result. It's connecting and running. So the addition 10 plus 3 13, and subtraction 10 minus 3 10, difference 3 7, 10 product B 10 product 3, A product B 10 product 3 30, and A division B, that is 10 division 3 3.333. So if you see here, it gives answers in the decimal point. decimal point, or if we search, it will do a type cast into float, and a float division, that is same answer, the quotient is 3, you just remove the decimal point and printed the 3. Finally, a modulus b, that means 10 modulus 3, it is giving a remainder 3, 10 divided by 3, so that means 3 multiplied by 3 equal to 9, so remainder is 1. Finally, we have a exponentiation power a power b, 10 power 3, so 10 product 10 product 10, so it's basically 1000. So these are all the examples for arithmetic operators. Then we proceed towards to assignment operators. That is the second one. Assignment operators. Basically, it is used to assign value to the variables. And what is operator? What is mean by operator? Operator determines action according to mathematics. And what is operand? According to mathematics, it either be data or variables or expressions. So to assign a value to a variable, we need operand. So in our case, we consider operand as a variable, or we simply call it as a variable. So let's assign a value to a variable. So the variable x is a variable, and equal to is the assignment operator. So this assignment operator determines action when this variable interact with another variable. So x is a variable, so let me assign value x equal to 5. If I print x, so the output is 5. So then where the assignment operators come? The assignment operator comes, it has some short form. For example, x equal to x plus 5, which means x already 5, and I am adding another 5, so which means 5 plus 5, 10. So if I print x, it is 10. Instead of adding like this, we have a short form of x plus equal to 5. It's same. Okay, so if I comment it and print x, it will be the same because it's a short form, which means x equal to x plus 5. So it was written in the short form. If we perform the same operation in the subtraction difference, so which means x equal to x minus 5, or maybe y, but y was not declared before, so it will throw an error. So let me declare y equal to 10 or 5. So y was successfully declared 5 and written like this: y equal to y minus 5. If we print y, it will be 0 because y already 5. I am subtracting 5 minus 5 and assigning 0 to the already existing variable called y. If we perform multiplication, z star, okay, and z equal to 5, and let me put different variable for division, equal to 2. So a actually 5, let's consider 5, it will give a 4 division value. So these are all short forms: x equal to x plus 5, y equal to y minus 5, z equal to z multiplied by 5, a equal to a 4 division of 5. The results are there. So instead of writing in the full form, we are writing in the short form. Then next operator is comparison operators. Let's see what is comparison operators. There are few different operators within the comparison operators. So this is used to compare values. The list of operators or list of comparison operators or equal, not equal, equal, greater than equal, or greater or equal, less or equal. It has own notation for each operator. So for equal, it is a double equal sign. It is completely different from assignment operator, because assignment operator is a single equal sign. But in the comparison operator, the equal sign used to compare values, not assign values. It's a double equal sign. For not equal, use exclamation and equal, and the notation for the greater is this, and notation for greater or equal is the combination of greater plus equal, and notation for less is this, and notation for less or equal is this. This comparison operator always evaluate values on true or false. So let's see some examples. A equal to 10, B equal to 20, and print of, let's say, let verify is both a variable have a same value. So in that case, A equal to B, and answer false, because it's not equal. So 10 equal to B, it's false. And if we print of A not equal to B, yes, it is true, the 10 is not equal to true. Print of A greater than B, again it's false, 10 is not greater than 20. So if I print A less than B, yeah, it is true, the 10 is less than 20. Let's run and see the output. Okay, 10 not equal to 10 equal to 20, 10 not equal to 20, yes, it is true. 10 greater than 20, no, it is false. 10 less than 20, yes, it is true. This is how comparison operator works. It actually always compare and evaluate and give the result in the Boolean form, which is true or false. Next one is logical operator. Let's see how it is. It has few types. Those types are AND, OR, and NOT. So AND condition, so these are all logical operator, it has its own conditions. Okay, so if both conditions are true, then output is true. If both conditions, if either of the one condition, either one of the condition is true, then okay, true. Else, so if in AND, else if one of the condition is false, then output is false. And in the NOT operator, it's simply the reverse result of the actual. For example, not true, which means false. Okay, and vice versa, not false means true. Okay, let's see some examples. Age equal to 46, and let's say some variable has ID, whether the person has ID, true. So let's see the examples. Okay, so age greater than 30 and has ID. Okay, so result is true. So here we apply AND condition. So that means if the both conditions are true, the output is true. The age is 46 greater than 18 is true, and does the person has ID card? Yeah, yes, he has ID card, because we assign the value called true. So the true and true, the output is true. But if either one of the condition is false, then output is false. For example, let's say age is 16 and the final output is false, because 16 greater than 18, no, false. But he has ID, but he is not eligible because of age criteria. So then result is false and true, because either one of the condition true, then the final output is always true. But if both of them false, then only the case the output is false. For example, if I give false, now result is false for OR condition, because 16 greater than 18 false, and does the person has ID? No, I assign the false value to ID column. So then false or false, the output is false. But if either one of them has true, then the output is true. It is a basic difference between AND condition and OR condition. And NOT is simply, for example, print of not true, it is false. Okay, correct. And if I print of not false, it just produce the reverse result, is one of the logical operators present in Python. And the next one is identity operator. Let's quickly see what is identity operators. Identity operators, it check whether two variables refer to the same object by using its own operator. Okay, so it checks whether two variables refer to the same object, and we have two types, is and is not. Let's have an example of few variables. A equal to 5, B equal to 5. Okay, if we compare A equal to B, it's a comparison operator we just saw here. Okay, this is completely different from identity operator. So because here we are checking the values assigned to the variables, so the 5 is assigned to variable A, 5 is assigned to variable B. So if I run, it will produce true. But identity operators check whether two variables refer to the same object. For example, the variable 1 A, the variable 2 is B, so both the variable assigned to the same value. So in that case, we have a function called id function to identify the memory of the variable. Identify memory address of the variable. Okay, let's see what is the memory of A. Print id of A. So the memory address of the A variable is 11654504, but the memory address of the B, it's same, 11654504. That's where the concept comes. For example, if we check by using identity operators, A is B. Okay, it is true because both are referring the same object, which is 5. So this 5 is stored in the same memory, 11654504. For example, if I assign the C equal to 5 and if I'm checking this C, so this also allocated in the same memory address, which means the 5 object is fixed and all these variables are pointing towards that object. And if I assign D equal to 6, definitely it will have a different memory address. Let's see. So this one D has different memory address because the assigned value is different. So the 6 value stored in the memory address 11654536. So the D is pointing towards this memory. So if we check A is D, which means we are asking the Python to check whether A and D refers to the same object. Answer is false. So false, and let us see what is not. So print A is not D true because both are different object. So the A is 11654504, D is 11654536. So A is not D. Yes, it is true. It is not same. And we have membership operators. Membership operators, it checks if a value exists in a sequence or not. Okay, the operators present in membership operators are in and not in. Not in, it is different from is and is not in the identity operator. So let's create a list called 1, 2, 3, 4, and we are checking. Okay, 10 not in number. Yeah, it is true, the 10 is not present in the list of values we provided, so it is true. And if we check 5 in numbers, this also false because 5 is not present. 10 is not, we are saying is 10 not present in number. Yeah, it's true. At the same time we are asking whether 5 present in the number. No, it's false. In the positive scenario, if I ask, okay, 1 is present in numbers, yeah, it is true because 1 is present. Okay, so the 10 is not present in the given list. Yeah, it is true, the output is true. The 5 is present in the numbers. No, false. 5 is not present in the numbers. 1 is present in the list. Yeah, it is it true? Is it true? Yes, it is true. And we are going to see bitwise operators. Bitwise operators, it is used for binary operations. So those operators are actually ampersand and the pipe. Okay, let's have a variable called A equal to 5, B equal to 3, and print of A ampersand 5. Let's see the A ampersand B. Let's see the output. Okay, so the 5 and 3, it is 1, and if we see A 5 B, it is 7. There are totally 6 different operators present in the bitwise operators. Let me list one by one. So ampersand for bitwise AND, pipe for bitwise OR, and upper cap for bitwise XOR, and we have 2 more, which is left shift. It is called left shift, and right shift. Difference between left shift and right shift. The difference is that here it shift the bits to the left side by multiplies the number by 2. But right shift, it's totally opposite. It shift bit to the right, but it divides by 2. Divides the number by 2. And we have one more, that is bitwise NOT. Its notation is tilde. Use of bitwise NOT is reverses all bits. For example, 0 becomes 1 and 1 becomes 0. For XOR, the result is 1 if bits are different. For bitwise OR, it's mostly same as our logical operator OR. Either one of this needs to be true, so the result is positive, that is 1 or true positive if at least one bit is 1. Okay, which means out of 2 at least one should be 1. So 1 or 0, so result is 1, or 1 or 1 also result is 1. If both are 0 and 0, the result is 0. And the bitwise AND is same as others. Okay, it compares each bit of 2 numbers, and result is 1 only if both bits are 1. And example, let's see, print A cap P for XOR, and so the result is 6. The print A shift or A not, that is tilde. Okay, not A, okay, not B. So result is -6. When it is 5, it is -6. When it is 3, it is -4. How is it right? So the 5, the bits of the 5 are 0 0 0 0 1 0 1. Okay, when we do a not operator, bitwise not operator, so this 0 0 0 0 1 0 1 becomes 1 1 1 0 1 0, because if you see the definition, 0 becomes 1 and 1 becomes 0. All this 0 becomes 1, that means one more 1, and the 1 becomes 0, 0 becomes 1, 1 becomes 0. The final output is 5 converted into 6. The same way for B as well. So then for left shift and right shift, for the left shift answer is 40, for the right shift answer is 0. A left shift be 40, A right shift be 0. If I summarize all the operators which we saw today, so there are 7 operators: arithmetic, assignment, comparison, logical, identity, membership, and bitwise. In the arithmetic, we have sum, addition, subtraction, multiplication, division. Okay, the quotient with a decimal point, floor division, quotient without decimal point, modulus only for remainder, exponentiation or power will give a result of that power. And example, and we saw comparison operator: equal, not equal, greater, greater or equal, less, lesser or equal. And logical operators, there are 3 logical operators: and, or, not. So if both conditions are true, output is true for AND. If either one of the condition is true, then output is true for OR. If it's a reverse, if it is true, the result is false. If it is false, the result will be true. And we saw identity operators. It checks whether 2 variables refer to the same object by using ID function. So by using ID function, we can see the memory address of the value assigned to the variable, and it has 2 operator, is or is not. If the memory address is same, is will produce true, otherwise it will result into false. Is not, just a vice versa of is. And we have a membership operators. It checks if a value exists in a sequence. It has 2 membership operators, in and not in. So it basically check the value exists in the sequence. And we finally saw bitwise operators, which is used for binary operation. It has totally 6 different operators. Bitwise AND, Bitwise OR, Bitwise XOR, left shift, right shift, Bitwise not. Thank you. Follow me for more such videos.